Decimal fractions have this nice relationship with powers of 10. They're part of what makes us give them this special notation in the first place. What happens when we multiply a decimal fraction by either a power of 10 or a fraction that is 1 over a power of 10? So for example, what do we get if we multiply 2.0735 times 100? Well, we'll have 20735 over 1, 2, 3, 4 digits to the right of the decimal point is 1, 2, 3, 4 zeros in the denominator times 100, if we'd like to write it as a fraction, will be 100 wholes. So we'll have, well, we know what happens when we multiply a whole number, such as 20,735 by 100. We just add 2 zeros on the end. Oh, but now we see that we can simplify this fraction, can't we? We can cancel one factor of 10 and another factor of 10. So in fact, this is 20735 over 100. In decimal notation, I'll just have the digits 20735, but now I only have 2 zeros in the denominator. So I only want 2 digits to the right of the decimal point. What happened? Notice that our product has exactly the same digits. It just has the decimal point 2 places further to the right. And just by analyzing the process that we followed here, this is always going to work that way, right? When we multiply a decimal by a 1 followed by some number of zeros, we move the decimal point that many places to the right. Notice the scare quotes around move. Decimal points are dots on a piece of paper. They don't move around. We write a new number that is different because its decimal point is 2 places further to the right. And we don't just do that. We do that because we are multiplying. So I'm going to show you another example. Suppose we want to multiply 0.17 times 1,000. Our answer will have the digits, well, 0, 1, 7. But we'd like the decimal point to be 1, 2, 3 places further to the right than it was here. In 0.17, the decimal point is between the 0 and the 1. 1, 2, 3 places further to the right. Oh, I only have 2 places to move it, which means I'll need a 0 as a placeholder. I get 170, which typically I will write without the leading 0. And if I'm still thinking about decimals, I might want to write it as 170 point. I'm going to give you one of these to try as well. Multiply 18.375 times 10. Pause the video and try it now. Well, again, in my answer I'll have the digits 18375. And I want the decimal point 1 place further to the right than it was in this number. In this number it was between the 8 and the 3. 1 place further to the right will be between the 3 and the 7. So my answer will be 183.75. All right, what about decimals that are a 1 to the right of some zeros? For example, what if I want to multiply 1.25 times 0.01? Well, the easiest way to go about this is to just do this normally. multiply 125 times 1, we'll get 125. And then I want 1, 2, 3, 4 digits to the right of the decimal point. 1, 2, 3, 4. We get 0.0125. When I multiply a decimal by a decimal with 1 as its only non-zero digit, like 0.1, 0.01, 0.001, I move the decimal point to the left. How many places? The same number of places that ordinary decimal multiplication would tell me to move it. Why am I doing this? Again, in fraction notation, 1.25 is 125 100ths. 0.01 is 1 100th. So the product, when I multiply the numerators, I just have 1 times 125. When I multiply the denominators, I have 2 more zeros in my denominator. So I place my decimal point 2 places further to the left. Notice there's only 1 zero to the right of the decimal point, but there are 2 zeros in the denominator. So I move 2 places to the left. This is an easy place to make off by 1 errors. So the best way to remember this is that it's just ordinary decimal multiplication. I'm going to give you one of these to try as well. Multiply 130 times 0.0001. Pause the video and try this now. Alright, remember that 130 is 130 point, so it has no digits to the right of its decimal point. Ignoring the decimal points, 130 times 1 is 130. I have 0, 1, 2, 3, 4 digits to the right of the decimal point. 1, 2, 3, 4 digits to the right of the decimal point. 0.0130. And if I like, I can leave off that trailing 0, 0.013.